Okay, I wanted to talk about an issue that I see coming up year after year, and I think maybe if I clear it up in a little video, it'll help you and others. And that issue is this. That is, if you have a charge, let's say you have two charges, and you want to know what the force is between them. I'll draw another charge here. And let's say they're separated by some amount. I'll call it 0.5 meters. And I'll say that this distance here is 0.4 meters, and this distance here is 0.3 meters. So we have all our distances accounted for. I'll do it like this so you can see it better.
Separately.
All right, and let's say that this charge here had a value of plus 2 microcoulombs, and this one here has a value of plus 2 microcoulombs. Size doesn't really matter for the example I'm showing you. And the way we proceed in determining the force between these two charges, which is going to be repelling, would be to find F equals K times Q1 times Q2 divided by R squared, where R is the separation right there. Okay? Now the question that is coming up, let's say we find this force, and we have 9 times 10 to the 9th, 2 times 10 to the minus 6th, 2 times 10 to the minus 6th, divided by 0.5 squared. That gives me 36 times 10 to the minus 3 divided by 0.25, which becomes 144 times 10 to the minus 3 newtons, or 0.144 newtons. Hope I got that right. All right, so that's what the size of the force is here. So if I redrew the situation, I'd have this. That is going to be the attractive force that either of these charges experiences. Let me make those clearer. So, actually, it's going to be repulsive. I'm sorry. They're going to be repelling each other because they're the same sign. Okay, so I have plus 2 microcoulombs, plus 2 microcoulombs. Okay, so I have these two charges repelling each other. And the question I'm often getting is, how do I find this angle here? The angle in between them. I need to find that angle in order to find the I hat and J hat components. That's later on we've done that. But the first step is to find this angle. And what I want to explain to you is you want to use either distances, which is 0.4, 0.3, or 0.5, or forces, 0.144. But I need to know what the size of those two forces are of these two legs of the triangle in order to find this angle. Since I don't have those, I can use this triangle because it's going to be the same. It's going to be a similar triangle to the other one, 0.5, 0.4, 0.3 meters theta. So I want to use SOHCAHTOA using these 3 same units. I have to use the same units if I want to do SOHCAHTOA. So I could say sine of theta in this case is equal to the opposite side divided by the hypotenuse. Or I could say cosine theta is equal to the adjacent side divided by the hypotenuse. Or I could say tangent theta is equal to the opposite side divided by the adjacent side. Any of those will work and give me the proper angle, 36.9 degrees in this case. But I can't start using this in here. I can't mix newtons and meters to find angles. I have to stick to the lengths of the sides. But whatever angle I get here will then be valid for finding the I hat or the x and the y components of this triangle here, because these two triangles have the same angles. It's just that this triangle's sides are in newtons and this triangle's sides are in meters. I hope that you find that helpful as you do problems that involve force, and for that matter, electric field also. You're going to have the same situation arising there. Okay.